Good morning. This is Ms. Billerbeck, and we're going to talk about 8.4 triangles. So we can construct triangles when we know the sum of the lengths of two sides is greater than the third side, the measure of two sides in one angle, and the measure of two angles and one side. All right, so here's a couple pictures of combined triangles in these cases, and I have one triangle there. Now let's take a look at the types of triangles that we have. All right, so when we're classifying triangles, we can classify the triangles by side. So we can have an equilateral triangle, which has three sides that are equal. So these little congruency ticks mean that they're the same length. If I have an isosceles triangle, it has two equal sides, which means I only have two sides that are marked with congruency ticks. And we have scaling triangles that have no sides that are equal. If we classify by angle, we have acute triangles have three angles that are less than 90 degrees. And a right angle has one angle that's 90 degrees. And obtuse triangles has one angle that is greater than 90 degrees. All right, let's look at some construction of triangles now. So in your examples, we have, well, what if we have actual lengths? So let's draw some. Okay, so when you're using MassPad, you can adjust the line width here and adjust the colors here. So I've already got my color all chosen, so let's to do that. Let me put that there. And we're going to draw 5 centimeters right here. All right, so if I'm going to draw a construction line, I want it very narrow, and I want to draw one of the sides as 4. Whoops, do that. Okay, there we go. Okay, so I'm going to move the needle here, and I'm going to stretch this out so it goes to 4 right there. And lock it in. And now I'm going to rotate it and just create a construction line. Now that's one of my lengths. So if I adjust this to 3, this is inches, I believe. No, it's centimeters. Sorry, this is UK. So these are 3 centimeters. Now I can move the needle to the other endpoint, and I can make an arc and have it intersect. So once I have that, I want to go back to a thicker line now that I've done my construction lines. And I can't start from this point when I'm using MassPad, but I can start from this point and lock in there, and this point and lock in there. Now this side is 3 centimeters, this one's 4 centimeters, so 3 plus 4 is 7, which means that it's greater than 5, which is one of the qualifications of having a triangle. 2 sides had to add to be more than the third side. So if we add 4 plus 5, that's 9, that's bigger than 3. 3 plus 5 is 8, that's bigger than 4. Okay, but what happens if we had one that was less? So let's take a look at that. All right, so if the 2 sides did not add up, let's say I had a side that was 3, whoops, let me go back to the construction line, and a side that was 1. Oops, let's just set that up here. And I'll move this around here. Well, we can see that if we rotate this, it never meets the other one. So we can't possibly connect them from the intersection, because 3 plus 1, and that's even bigger than 1 because I missed it, but 3 plus something that's less than 2 is not going to equal 5, so we can't make a triangle. So the two sides have to add up to be more. Well, what if we actually use 2? So let me stretch that out, and we'll undo that one. And what if we actually use 2 and just did them equal? Well, can we make a triangle out of that? No, we can't, because the intersection is right here, and it would just be a line over a line. So it has to be something that's bigger than 5. So 3 plus 3 is 6. So that would make a triangle, because now we have an intersection here. So that's why we have to have the two sides have to add up to be more than the third side. Otherwise, we can't make a triangle. Okay, the other qualification of making a triangle is you have to have the measure of two sides and an angle. So if we had these two sides and some angle, we could make a triangle. Okay, or the measure of two angles and a side. So if I had two angles here, and one side, angles look like this. If I have an angle like that, and I have a third angle like that, I can always make a triangle by extending out the sides. Okay, so that's why it says the measure of two angles and a side. So if we knew this side and the two angles, we could connect this 2 points. All right, so that is, let's do another example on making a triangle, but we'll use, this time we'll use an angle. Okay, so we have construct a triangle using 5 centimeters and 5 centimeters and 40 degrees. Okay, so let's do it. So we're going to set this up here, and I'm going to stretch this out to 5 and lock that in. And I'm going to move this to a construction line. And there we go. And rotate. Okay, so I know that. And I also know one of the sides. So I'm going to draw from here off to there. Okay, so I know one side's 5, and I know the other side's out here at 5, but I don't know where. But I do know it's at 40 degrees, so I can use this with a protractor and line this protractor up right there. And I see I have 40 degrees right here. So I can take up a line. Let's make it a construction line, and we'll fix it up later. So 40 degrees is right here, so we can set it like that and go and line it right there. Okay, now we can move the protractor, and look, we can draw a triangle now. So we have an angle and two sides. So we can start from here, go down there, and start from here and go here. And there's our triangle. That was easy. All right. So what if we have just one side and two angles? So let's see what that would look like. Okay, so let's draw this one here. We're going to draw 5 again. Oops. And we're going to use this protractor. So So let's say we have a 40-degree angle. So we'll use a construction here. So let's make it 50 degrees this time. So we're going to start at 50 and head down here. Okay, and then we're going to move this, and we know the other angle. So let's say it's 60. So we start here at 60, and we take it down to there. Okay, so now we just put a thicker line to show where this triangle is going to be. We start at that intersection where the two angles met. 1 and 2. So that's how we would construct it using the measure of two angles on one side. And we looked at how to construct it with two sides in the measure of one angle and the sum of, and we also looked at if we knew three sides. So that's it for this lesson, and I hope you have a wonderful day. Let me find, there's my Google Meet. Bye-bye.